Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. So today I'll discuss how to determine least value of force which is required for impeding the motion of the block. So I have a numerical here. So wherein I have two blocks, one is block A and one more is block B. So block A is having the self weight of 2 kilonewton and block B is having the self weight of magnitude equal to 4 kilonewton. So block A is on the inclined surface and block B is placed on the horizontal surface. So here one more thing you can just observe over here, block A and block B is connected through the cable to the frictionless pulley. So here since both are interconnected through the cable, so obviously the cable will be subjected to tension force or tensile force. So when the block is subjected to or connected to the cable, so the cable will always be subjected to the tensile force. So here you can just observe one more thing, that block B is subjected to the force of magnitude equal to P. So this P force is an unknown force which is inclined in nature of magnitude equal to P and which is inclined with the angle of theta. So this is inclined at an angle of theta. So in the numerical they have mentioned that, so we need to find what is the magnitude of P which is having the least value and which pulls the object both A and B towards left side. So whenever B is pulled towards left side, so if this is a direction of the motion trend, so A will be obviously moved in the upward direction. So they are telling that the P is the force which pulls the overall system towards the left side direction, which interconnected that the A will be moved in the upward direction. So again they have mentioned that coefficient of friction for all the contact surfaces is equal to 0.3. So we know that coefficient of friction is nothing but the ratio of frictional force to the normal reaction. So that is the coefficient of friction. So they have given it as 0.3. So they have given it as 0.3 and it is common for all the contact surfaces. So next, coming on to the sketching of the free body diagram. So first I am going to consider the block A, which is having the self weight of magnitude equal to 2 kilonewton. So if I just draw the x and y axis, this black color line indicates the x and y axis of the block. So if this is the normal x and y axis, so 2 kilonewton, it is on the inclined surface with the inclination of 30 degree means, so 2 kilonewton will be inclined at same angle of inclination 30 degree with reference to vertical. So therefore this 30 degree is with reference to vertical. So therefore, so the vertical resolution of the force will become 2 cos 30 and this will be 2 sin 30. So I repeat it. Since the overall plane is inclined at an angle of 30 degree, so therefore if I just draw the xx and yy axis of the block, so the self weight will be also inclined at an angle of the 30 degree, the same angle with reference to the vertical axis. So therefore the vertical resolution will be 2 cos 30 in the downward direction and the horizontal resolution will be 2 sin 30 in the right side direction. So apart from that, so since this is a block A, as I said that the P is the force which is responsible for the motion of the overall system. So wherein the P is moved in the left side direction. So if the P is moved in the left side direction, the block B will be moved in the left side direction, and the block A will be moved in the upward direction. So therefore the motion trend will be in this direction. So as soon as the motion trend will be in the upward direction, obviously the frictional force will be in the opposite to the direction of the motion trend. So this is the direction of frictional force. I just call that as F2, and N2 is the normal reaction which lies exactly on the YY axis of the block. So apart from that, we can just observe in the question that they have both the blocks are connected through the cable. So since, as I said in the earlier explanation itself, so since it is connected through the cable, there will be the existence of the tensile force. So therefore this is the tensile force due to the cable. I just call that as T. So this T is the tension force existing between the A and B through the connected cable. So next is I need to resolve these forces for determination of its unknowns. So first and foremost is sigma h, that is summation of all the horizontal forces is equal to 0. That is the first equilibrium condition. So if I want to consider the sigma h, then only I need to concentrate on the horizontal forces. So I have 2 sine 30 T, and then one more is F2. All these are the horizontal forces. So for solving the horizontal forces, right side force is considered to be as positive and left side going forces is considered to be as negative. So if this kind of sign convention, if I want to proceed, 2 sine 30 is going in the right side direction, hence it is positive. F2 is also going in the right side direction, hence it is positive. But T is going in the left side direction, hence it is negative. Equate that to 0, you will get one equation of sigma h. So next is sigma v. Summation of all the vertical forces is equal to 0. So while solving this equilibrium condition, I have the sign convention. Upward force is considered to be as positive and downward force is considered to be as negative. So here I have the forces in the vertical direction as 2 cos 30, which is going in the downward direction, and N2 is going in the upward direction. So therefore 2 cos 30, which is going in the downward direction, so it becomes negative minus 2 cos 30, and then N2 is going in the upward direction, so therefore it is positive value. So therefore N2 minus 2 cos 30, I have got the value. So further, if I just wanted to simplify that, I'll get the value of N2 as 2 cos 30, or still if I just simplify the 2 cos 30, I'll get the value of N2 as 1.73 kilonewton. So after getting the value of N2 as 1.73 kilonewton, so I know that N2 is an indirect value of F2. Why? Because we know the relation, the coefficient of friction is equal to F by N. The coefficient of friction is equal to F by N, but in this case it is F2 by N2 is equal to 0.3. So N2 value I have determined it as 1.732. So F2 I want to determine, and 0.3 is the coefficient of friction. So if I just cross multiply 0.3 and N2, I get the value of F2 as 0.52 kilonewton. 0.52 kilonewton. After getting the value of F2 as 0.52 kilonewton, so I know the equation of horizontal equilibrium. So this is the equation. So if I just substitute the value of F2 as 0.52, I'll get the value of the unknown tension force, that is a T force, as 1.52 kilonewton. Upon simplification, I get the value as 1.52 kilonewton. So next, coming on to the next free body diagram sketching, that is for block B, which was inclined on the horizontal plane. So here for the block B, So the self weight, since it is the surface is not inclined, it will be exactly lying on the horizontal plane, means the x-axis and y-y axis of the plane will be coinciding with that of the block. So therefore 4 kilonewton is exactly on the top of the y-y axis, and then T is exactly on the x-x axis. So T is the tension force due to the cable, and N1 is the normal reaction. 4 kilonewton is will be exactly on the y-axis because it lies exactly on the horizontal plane without any inclination. So again, P is the force which is responsible for the motion of the body. So in the question itself they have mentioned that it is going in the left side direction, so the motion trend will be again in the left side direction, so which we can determine the value of F1, that is the frictional force, has in the right side direction because of the opposite nature. So we know that P is inclined at an angle of theta. So we, upon resolution, the vertical component will be P sin theta and the horizontal component will be P cos theta. So upon all this, if I want to proceed, sigma h is equal to 0. Sigma h is equal to 0. That is summation of all the horizontal force is equal to 0. So summation of all the horizontal force is equal to 0 means, so here we have the horizontal force of P cos theta, and F1 is the horizontal force and T is also the horizontal force. Left side force is considered to be as negative, right side force is considered to be as positive. So therefore P cos theta plus T plus F1 is equal to 0. So we know that F1 by N1 is again equal to 0.3 itself. Why? Because in the question they have mentioned that coefficient of friction for all the contact surfaces is equal to 0.3. So therefore F1 can be treated as 0.3 times of N1, 0.3 times of N1. So this is the value, and then the next step is we need to substitute the value of F1 in the equation of sigma h. So in this equation we are supposed to substitute the value. So this is the overall expression. So next thing is that the sigma v, summation of all the vertical forces, is equal to 0. So here we have the vertical forces as P sin theta, and 4 is acting in the downward direction, which is equal to negative value, and N1 is the positive value. So upon simplification I'll just get that as P sin theta minus 4 plus N1 is equal to 0, minus P sin theta minus 4 plus N1 is equal to 0. So if I want to calculate easily, so N1 is equal to express N1 in terms of theta, so and P. So N1 will be equal to 4 minus P sin theta. N1 is equal to 4 minus P sin theta. So I need to substitute that N1 value, which are in terms of 4 minus P sin theta, in the equation 1. So therefore the equation 1 becomes, so P cos theta plus 1.52 plus 0.3 into N1 value is 4 minus P sin theta. So equate that to 0. And upon simplification I'll get the value as P cos theta plus 0.3 P sin theta is equal to 2.72. So this is the final value of the simplification of the sigma h and sigma v. So now, after getting the value of the in terms of equation, we are supposed to find out what is the unknown for the overall system, that is in terms of P and theta. So for that we are supposed to determine the least value of theta. So least value of theta, if you need it, we need to differentiate the value of P with reference to theta, and we are supposed to equate that to 0. So therefore dP by d theta, that is differentiation of P with reference to theta is equal to 0. We are supposed to equate the differentiated value to 0 because you are supposed to find out what is the least value of P. So next is we have this expression from the previous slide reference. We have this expression which we have got by using sigma h and sigma v. So that equation we are supposed to differentiate with reference to theta. So therefore it will be minus p sin theta plus 0.3 p cos theta is equal to 0. So I just bring this term to the right hand side. So it will be further simplified as tan theta is equal to 0.3. So theta is equal to 16.7 degrees. So this is how we are supposed to calculate what is the value of theta. So the next step is, after calculating the value of theta, so I need to substitute in the equation of theta the value of theta. I need to substitute the value in the expression. So I have the expression as p cos theta plus 0.3 p sin theta equal to 2.72. So there p cos 16.7 plus 0.3 p sin 16.7, whichever the value we have got for theta, the same value we are supposed to substitute over here. So get the value of p. So I have got the value of p as 2.6 kilonewton. 2.6 kilonewton. So this is how we are supposed to calculate what is the least value of the impending force system. Thank you for watching. Please like, share and subscribe the video. Thank you.